guys. Welcome to my review and notes of a brief history of the atom, including the atom guys. If we were in a normal day of school, I would have asked you to get out a sheet of paper and write atom guys at the top of it, and then just copy down everything that I write as we go. It'll really help you out later on. So, brief history of the atom. Today's slideshow is just going to tell you about the different theories and ideas that people have had about atoms over the years. Here are a couple of the important ones that we need to pay attention to and who thought it up. So the first person you need to know about is Democritus. So Democritus was a Greek philosopher. He was kind of one of the first scientists. Scientists didn't really exist all that much, but they were philosophers because we didn't have all of the scientific tools that we have now. So that means that they had to have ideas about stuff. They had to philosophize. So Democritus, we talked about in the first set of notes, the ones with the Twinkies on it, when I cut up the pieces of aluminum foil. And we talked about the fact that his idea was that if you took any piece of matter, cut it in half, and then take that piece and cut it in half and do that over and over again, eventually you'll get to a particle that is uncuttable. A particle that if you were to cut it any smaller, it would no longer be that item. And in Greek, atomos means uncuttable. So guess who gave us the name for the atom? Democritus. So if we were in class, I would say, I say Democritus, you say atomos, Democritus, atomos, Democritus, atomos. It's a lot more fun with y'all in the room. Anyway, what are we writing down? Guess what? Democritus, atomos. And you're going to remember that means uncuttable. All right, we do not have a model to go along with Democritus because he didn't really have any ideas about what it looked like. He had ideas about how it behaved. So moving on. So number 2 is John Dalton. So John Dalton was a British chemist. He believed that atoms cannot be divided or destroyed. Now, do we know that to be true? Right, exactly. We figured out you can divide an atom. It's a big boom, but we can do it. Atoms of the same element have the same mass. He was right about that. Atoms of different elements have different masses, and he was sort of right about that. He said elements combined, they do so in predictable ratios and amounts. He was right about that. And we think of him as the marble man. Marble is going to be our key word here because he believed that the atom looked like a small solid sphere, like a marble. So his model of the atom was just a small solid sphere, like we were just made up of compact solid little beads. So when I say Dalton, you say marble. Dalton, marble. Dalton, marble. Democritus, atomos. Democritus, atomos. Good job. All right, so that's what we're writing down. Dalton. And then our key word for him is marble. And then we're going to draw a marble to remind us that his model was just a plain marble. Next up is Thompson, J.J. Thompson. He believed that atoms do have something smaller besides the solid piece. And he was right about that. He said the atom is like a positively charged ball with negatively charged electrons stuck in it. And he knew that atoms were neutral. They had a neutral charge. So he figured that the negative charges in the electrons and the positive charges in the neutrons balanced each other out. And he was right about that. Yeah, muffins. So his model looks like a perfectly round blueberry muffin, where the cake part is the positively charged part and the little blueberries inside are the negatively charged electrons. So when I say Thompson, you say muffins. Thompson, muffins. Thompson, muffins. Dalton, marble. Dalton, marble. Democritus, atomos. Democritus, atomos. Okay, guess what we're going to write down? That's right. We're going to write Thompson And then our keyword for him is muffin. And then we're going to draw our positively charged blueberry muffin with the negatively charged blueberries inside. Okay, let's see who's next. Rutherford. Ernst, that is not correct. His name is Ernst. Now, Ernst in Americanized is Ernest. So that's why. But his real name, his given name is Ernst. So Ernst Rutherford believed that the atom was mostly empty space. So he looked at Thompson's model and Dalton's model of it being solid. You know, granted, Thompson's model had different pieces, but it was still solid. And he was like, I don't know. I think the atom is mostly empty space. And he was right. A long time ago when he came up with this, he was right. It's really incredible. He believed that atoms had a small, solid core. He was wrong about that. He believed that it was a solid core in the middle, kind of like Dalton's marble. But then the outside of it was empty space, and the electrons just floated around on the outside. So his model can be drawn kind of like the model that you see on The Simpsons for an atom, just showing that empty space. So you can guess it. When I say Rutherford, you say empty space. Rutherford, empty space. Rutherford, empty space. Thompson, Thompson, Dalton, marble. Dalton, marble. Democritus, atomos. Democritus, atomos. All right. So what are we going to write down? That's right. Rutherford, empty space. And then we need to draw a model that looks kind of like that one. Good old Rutherford. Our keywords are empty space. And then we're going to draw a model that looks kind of like the Simpsons model. And the way you do that is put your nucleus in the center, and then an oval going one way, oval going another way, oval going another way. Next up, we've got Niels Bohr. Niels Bohr was the one who really figured out a lot of stuff about the atom. And the Bohr model of the atom is the one that's used the most often for teaching. So later on, when I'm talking about different structures of the atom, I'm probably going to use Bohr's model rather than the actual accurate one, because it's easier to see. It's easier to use to teach. It's easier to learn about where the electrons are and all that. So Bohr's model is not the most accurate, but it is the one we use the most. So in Bohr's model, the atoms have energy levels or rings that the electrons move in. The more energy the electron has, the farther it is from the nucleus. The energy level farther from the nucleus hold more electrons. And if you change the energy of electron, it's going to change its energy level. So if you add energy to the atom or take energy away from the atom, then the electrons are going to change levels. So his model looks like this, rings. And you've probably seen something similar to this. Like I said, it's been used a whole lot. So I bet you can think of it, right? Ring, Bohr, ring, right? Got it? All right, so I say Bohr, you say ring, Bohr, ring, Bohr, ring. Rutherford, empty space. Rutherford, empty space. Thompson, Thompson. Dalton, marble. Dalton, marble. Democritus, atomos. Democritus, atomos. All right, so let's write that one down. We've got Bohr, and his rings, and our picture is going to have a nucleus at the center, and then rings with electrons orbiting around. I think you can see that. Hopefully you can see that. All right, next up is James Chadwick, also known as Jimmy Neutron. So James Chadwick was a British physicist who in the 50s, I believe it was 40s, discovered the neutron. So up until him, we didn't know the neutron existed. We knew protons existed because there were positive charges. We knew electrons existed because we knew that the charges became neutral, and so there had to be a negative particle there. But since neutrons are neutral, we didn't know they were there for a long time until finally this guy was like, wait a minute. The mass inside of an atom is too big to be just the protons. There's got to be something else in there. And he's the one that figured out that there are particles that are just as heavy as protons, but that have no charge in the nucleus, and they're called neutrons. And you remember Jimmy Neutron, the TV show? I mean, look, you know what a caricature is? A caricature. So like if I was to go to a caricaturist, they would probably draw really big glasses and long hair, because those are two things that like stick out, and they might make it kind of frizzy or whatever. Just because caricatures, you take it as something about the person and blow it up bigger than it really is, right? So check out the eyebrow, the forehead on this guy, right? Like, what did they do to our friend Jimmy? The hair. That's who Jimmy Neutron was based on. It's James Chadwick. It was Jimmy Neutron. Like, check it out sometime. Anyway, so why Jimmy Neutron? Well, because James and Jimmy, like Jimmy is a nickname for James, okay? And then he's the one that discovered the neutron. So when I say James Chadwick, you say Jimmy Neutron. James Chadwick, Jimmy Neutron. James Chadwick, Jimmy Neutron. Boring, boring. Rutherford, empty space. Rutherford, empty space. Thompson, Thompson, Dalton, Dalton, Democritus, Atomos, Democritus, Atomos. All right, let's write it down. I'm including the J so that you'll remember why we're calling him Jimmy Neutron. And then we do not have a model to go along with Chadwick, because he really didn't change the model any. He just said there's neutrons in the atom. So you don't need to draw any models for him. All right. Our modern idea of the atom. Warning, warning. Ms. Harris can only tell you what the most recent understood thing of science is. If you read an article and it says something opposite of what Ms. Harris says, it just means I haven't read it yet. Point it in my direction and don't get mad at me. Okay. Right now, we believe you can never know exactly where the electrons are in the electron cloud at any given time. We do agree with Bohr that there are rings, energy levels in the cloud, but they aren't in those perfectly concentric rings like a solar system. They are all over the place and make all kinds of crazy shapes. When electrons change levels, they give off or absorb energy, which can be observed as heat, light, or other forms of energy. Ever used a glow stick? You were observing electrons jumping energy levels and giving off light. Most of the mass of the atom is in the nucleus. Most of the volume is in the cloud, which gives the atom its size. Now, a guy named Erwin Schrödinger is the one who is credited with giving us our modern model. So that's the guy we're going to stick with. And you can see the modern model is trying to make it more accurate. The modern model is trying to make it look more like a real live atom. Because a real live atom isn't a solid sphere. A real live atom is a dense center and then major empty space electrons flying around. Is this a great one to view, to learn from? No. But if we want accuracy, this is what we need. So when I say Schrödinger, you say modern. Schrödinger, modern. Schrödinger, modern. James Chadwick, Jimmy Neutron. James Chadwick, Jimmy Neutron. Boring, boring. Rutherford, empty space. Rutherford, empty space. Thompson, Thompson. Dalton, Dalton. Democritus, Atomos. Democritus, last one. Yes, Atomos. Whew. My goodness. Okay, so let's get that one written down. We'll go back to red. So Schrödinger is his name. Modern is his model. And for the model, you're just going to do dots. That's basically all you can do. All right. Thank you for joining me yet again. Have a lovely day. Bye.